Python programming language. Python numeric data types. A Python number can be Python int, Python float, or even Python complex number. A number is an arithmetic entity that lets us measure something. Python allows us to store the integer, floating, and complex numbers and also lets us convert between them. Since Python is dynamically typed, there is no need to specify the type of data for a variable. So now let's start with Python number types. None. The none keyword indicates the absence of value. Python int. Python can hold signed integers. It can hold a value of any length, the only limitation being the amount of memory available. There are 3 int types of Python number types. Python type, function. It takes one argument and returns which class it belongs to. Python isInstance, function. It takes 2 arguments. The first is the construct, x a variable or a list, and the second is a class. It returns true or false based on whether the construct belongs to that class. Since it belongs to the class int instead, it returns false. Python exponential numbers. You can write an exponential number using the letter e between the mantissa and the exponent. Remember that this is power of 10. To raise a number to another's power, we use the operator. Python float. Python also supports floating-point real values. An int cannot store the value of the mathematical constant pi, but a float can. A float value is only accurate up to 15 decimal places. After that, it rounds the number off. Note that division results in floats. Python complex numbers. A complex number is a Python number type made of real and imaginary parts. It is represented as a plus bj. Here, 2 is the real part, and 3j is the imaginary part. Coefficient to the imaginary part. To denote the irrational part, however, you can't use the letter I, like you would do on paper. Also, it is mandatory to provide a coefficient to the imaginary part. In this case, a coefficient of 1 will do. Coefficient to the imaginary part. Finally, you can perform basic operations on complex numbers too. Here, asterisk equals is an in-place assignment operator. Writing numbers in binary, octal, and hexadecimal in Python. More often than not, programmers need to deal with numbers other than decimal. To do this, you can use appropriate prefixes. Binary numbers in Python. Most of us are familiar with decimal numbers, but sometimes we need to work with other systems. For binary numbers, use the prefix 0b or 0b. For example, 7 in binary is 0b111. You can also apply conversion functions on these numbers. Octal numbers in Python. Octal numbers use the prefix 0, o, or 00. But be careful. Octal numbers only have digits 0 to 7. Trying to use 8 will cause an error. Hexadecimal numbers in Python. These numbers have digits 0 to 9 and AF. Hexadecimal numbers use the prefix 0x or 0x. Python conversion functions. Although most times Python does the conversion as needed, you can do it explicitly if you want. These functions allow us to convert one numeric type into another Python numeric data types. Int in Python. Python has built-in conversion functions that allow us to convert one numeric type into another. For example, int function can convert another numeric type into an int. It's important to note that int doesn't round the number up, it truncates the decimal. Also, you can't convert a complex number into an int. But wait, there's more! We can also apply int to representations other than decimal, i.e., binary, octal, and hexadecimal. Float in Python. This function converts another numeric type into a float. Like int, float can't convert a complex number either. Here, we applied it to an octal number. Complex in Python. The complex function converts another numeric type into a complex number. Bin in Python. The bin function returns the binary value of a number. However, you can't apply it to a float value or a complex value. Oct in Python. This function returns the octal value of a number. We know that 8.0 is the same as 8, but the function doesn't think the same. It is a float, so it cannot convert it into an oct. Hex in Python. The hex function returns the hexadecimal value of a number. Python decimal module. Let's try out adding 1.1 and 2.2 in the shell, and let's compare it with 3.3. Why did it return false? Let's try printing the sum. Whoa, how did this happen? Well, this is duly attributed to hardware limitations, and is not a flaw of Python. Because the hardware stores decimals as binary fractions, it isn't possible to store it very accurately. Let's take an example. When we divide 1 by 3, it doesn't return the full value, which is 0.33333333333333. Python does provide a solution to this problem. It has the decimal module, which lets us choose precision. Did you see what happened here? The decimal function preserved the significance. Fractions module in Python. Another module that Python provides, the fractions module, lets you deal with fractions. The fraction function returns the value in the form of numerator and denominator. It can also take two arguments. Math module in Python. Another essential module in Python is the math module. It has all important mathematical functions like exp, trigonometric functions, logarithmic functions, factorial, and more.